open up to Notes 5, Example 2. We did Example 1 in Notes 5 last week, didn't we?
We did.
So, the circuit that we drew for Example 1 looked something like this. Transformer. Okay, I'm just drawing the circuit of page 1, example 1. We have a transformer, primary winding, secondary winding. On the primary side, I've got a voltage coming in, 120 volts, 60 hertz. The turns ratio of the transformer is how much? How much is it? 15 to 1. And I have a diode to make it into a rectifier circuit. So I put a diode right here. And that makes it a rectifier circuit. What is a rectifier circuit? That converts AC into DC. That's what rectification means, converting AC to DC. Okay? One diode will convert it to DC. So, I have a load connected here in the form of a resistor, 1K. Okay? And I calculated V secondary RMS, V secondary peak, V out peak, V DC average, IDC average. I did all that. On page 2, I drew the graph of V out, the voltage here, V out. What did the graph look like? Here's the V secondary with a peak value of how much? What was my peak value on page 2? 11.3 volts. And then underneath it, I drew the graph of V out. You have to show the 0 volts in the middle. Okay? And for each of my positive half, I have a voltage present. Right? So that's what V out looks like. And it's because I have a positive half and a negative half of my voltage coming in. During the positive half, the polarity is plus minus, which makes the diode forward biased or reverse biased?
Forward.
Forward biased. That's for the positive half, plus minus. For the negative half, the polarity changes to minus plus. Now, is the diode forward biased or reverse biased?
Reverse.
Reverse. So when it's reversed, it's basically open, and if it's open, the voltage at the resistor is 0. So that's why we showed that. Okay. And then we said that the average voltage is what V out is. And that average voltage, VDC average, is equal to V rectified peak divided by R. Right? So that's what the DC average turns out to be, which worked out to how much? What was the answer at the bottom of page 1?
338, 3.38.
3.38 volts. Now, what I want you to do for example 2 is redraw that circuit, but add a capacitor now. So we're going to now add a capacitor. So draw the very same circuit, but do this. Add a 200 microfarad capacitor across the load. We always connect the capacitor right across the resistor if the resistor is the load. So this is the circuit of example 2. It's the same circuit as the one for example 1. All I did was I connected a capacitor, and it's called a filter capacitor. The reason why we use the word filter is because it's going to improve the output voltage. from something that looks like this to more of a straight line. Also called a ripple voltage. I'm on page 3, example 2. The polarity of the capacitor is important. We're dealing with capacitors in a DC circuit, and even for the lab, when we work with the capacitors in the lab this week, they're big capacitors. 200 microfarad is a fairly large capacitor, and if we connect it backwards, there is a possibility of the capacitor popping or exploding. So you want to make sure you bring your safety glasses this week and wear the safety glasses to the lab.